Hello everybody. My name is Cameron McConnell. This is my CSE 434 socket project. All right. So for today, this video, basically what we're going to do is we're going to have the tracker that's going to be hosted on General 3, and the 4 users that are going to be using the tracker for the video are going to be on the other ASU general servers. So we have 4 and 5, and then also at the same time there's some stats servers apparently. So you'll see stats 3 and stats 4 are the other servers that will be hosting the clients. Okay, so for now, what I'm going to do first is I'm going to swap over to the terminals, and I'm going to start connecting to or I'm going to start up the processes and just begin showing you what it's going to look like. Share my screen. Okay, so first what we're going to do is we're going to start up the server in General 3. So here what we're going to do is we're going to be using Python 3 to compile it due to the fact that some of the libraries require Python 3 and up. I'm going to call the server.py file and pass a port number of 1600 to the tracker or server. So upon starting it up, you're going to see that we're giving the address or the IP address for the current general server, which is going to be 10.120.70.106. So now we're going to go to General 4, and we are going to start the client process. See here, we're compiling it with Python 3, client.py. We have the IP address for the tracker, which as you can see, the two match, and also the port number for the tracker process, which is 1600. Okay, as you can see here, we're open, or we're just giving a menu of basically the inputs and the arguments for each input, what it expects. As you see, for first one, we have register, which takes the handle, an IPv4 address, port number, which is between 1600 and 497 due to our group number and the formula for the minimum and maximum port number that our group number could use. Since we are group 30, so we're an even group, and so this was the range that we could use. Next, I'm going to start the process on the rest of the servers. So here I'm going to do it on General 5. Up over to the stats servers, and same thing. Stats 3, down to stats 4. Okay, so now we have clients started on every single server. So now we're going to move over back to General 4, and first things first, what we're going to do is I'm going to show you trying to register a character or just a handle. So we're going to do the register command, name this one Alex. The IP address for this process or this server would be 10.120.70.145, and we're going to use port number 1601. There you go. You can see we get a success not only on the server side, but also on the client side. So what we can do here is if we ask to register Alex again, 110.7, let's do the same command. We receive the message that, well, the current user has already registered. The way that I set up the program was that once the user was registered, there'd be no way that the current user could re-register with a different name. So once you register with a specific name, IP address, and port number, you are locked into those ports and or that username or that handle, IP address, and port number until you exit the program using your handle. Now what I'm going to do, so I'm going to go through, and if you want to see here, what I can do here with this process is I can give the exact same name, but I can use the different IP address for this server. This 70, 117, and then we'll do 1604. And as you can see, the message should return, yep, failure. User not added since it was a duplicate handle. And remember, we registered Alex in the previous process on the other server. So this time we're just going to redo the command, but we're going to use the name Bill. Similar parameters, 1604. And as you can see there, we registered Bill successfully. So now we're going to swap over to this side of the terminals. There we go. And we'll do the same. So for stats 3, we're going to register Cameron is going to be 10.120.70.109. Then we're going to do port number 16007. Success. And finally, we'll do this here. This. And 120.70.157. And then we'll do 160.10. And not only is it assigning, port number between the tracker and the current client process, but also at the same time, it's creating a port that is used for listening for a tweet coming in, and also at the same time it assigns a port for sending out tweets that is used to propagate along the logical link that I've basically implemented using these different programs. All right, so now that we've registered all these users and I've shown an example of a failure upon trying to register and a success, I'm going to move to querying the handles. So let's go move to, actually, use this one. Use stats 3. I'm going to do the command query handles, and I'm going to return a tuple, a 2-tuple of the, what is it called? The current users, registered users. As you can see there's all the registered users, as well as the current number of users registered, which is 4. So now what I'm going to do is, after I've done that, I'm going to begin creating the logical links. So the idea for what I'm going to do for this part is I'm going to have Alex be followed by Bill, Cameron, and Dick. And then I'm going to have Bill followed by Alex, Cameron, and Dick. And so the idea is the way it's going to be propagated. So if Alex tweets, it's going to go to Bill, then to Cameron, then Dick, and then it'll return to Alex, and it'll send an end tweet to the tracker. Tracker should finish, and it'll signify that it's propagated the tweet throughout the logical link. Then I'm going to have Bill do the same, and it should go to Alex, then to Cameron, then to Dick. After that's finished, I'm going to have Cameron unfollow Alex, and we'll send the tweets again. So the idea is the tweet is going to go from, instead of, from Alex to Bill, Cameron, then Dick, it's going to go from Alex to Bill to Dick, and then back to Alex. And since Cameron is still following Bill, it should still stay the same. So as I'm going to show you, I'm just going to go through right now. For Alex, I'm going to follow Alex, and I'm going to have him follow Bill. Now also to show an example of a failure, I'm going to do follow. We'll do Alex, and then we'll just do some names. So we'll do like Bon Jovi. And as you can see there, we'll get a message back from the tracker saying that, well, Bon Jovi is not a registered user. So there was a failure there. Also at the same time, we can do something like follow. Actually, it's some other stuff that's already implemented, but there's a bunch of other different cases, but I just show one case of such failure currently. So now Alex is following Bill. So I'm going to go over here, swap to the window. I'm going to do follow Bill, Alex. Cool. Now I'm going to switch to this next window. We're going to follow Cameron, Alex, follow Cameron, Bill. Finally, we're going to follow Dick, Alex. Oops. I see there. Yeah, not a registered user, follow Dick Alex. I'm gonna do follow Dick Bill. Cool. So now if I go over to Alex and we have Alex tweet, we're going to do tweet, the command tweet, and we're going to do current handle followed by a tweet. And so for the tweet, we're just going to do hello world. And after I press enter, we'll see that it propagated and we'll get a return message from the server. There we go. So it was pretty quick. It pretty much went through immediately. So we can follow my cursor here. We can see that success, Alex has completed its propagation, right? What we can do is we call the tweet, yada, yada, yada. That's basically the only message that Alex is going to get. Here we see tweet from user Alex has completed its propagation, and also at the same time starting, which is propagating the tweet from user Alex to followers, and then we get the return message as success. Then we can check each user individually. And so we can see here, this is how we have Bill, and we have followed user Alex has tweeted hello world. Previous data from handle Alex, port number 1602, which is the sending port of Alex and the IP address for Alex. Next, we have sending the data to handle Cameron, which if you follow alphabetically, it's Bill, Cameron, and then Dick. If we see Cameron, it's going to be sending to Dick. It's going to be IPv4 address. And port number 16009. Cameron. Let's see, previous data from Bill, port number 16005, the address. And then sending to port number. Then finally, we can see here, down here at Dick, previous data from Cameron, port number 1608, yada, yada, yada. Sending data Alex, which is our original in the logical link, and Alex then sends the end tweet to the tracker process, and the process basically kills the tweet. Okay. So next, if I go to Bill real quick, I do tweet Bill, hello again. We'll see here that first it's going to go to, what's it called, Alex. Then we have it go to right here, Cameron. And then it's going to go to Dick, from Cameron, back to Bill. So now what we're going to go do is we're going to show you the drop command, and I'll show you a failure of it first. I'm going to do drop Cameron Carl. See there, Carl is not a registered user, so there's an example of a response for failure. Now what I'm going to do is I'm going to instead do drop Cameron Alex. We get a return success. User Cameron has followed Alex unsuccessfully. So now I'm going to tweet from Alex again. Alex, hello world again. Boom. So this time we'll notice that we didn't get a tweet from Alex and Cameron. So instead, it first got sent to Bill, then to Dick, because Bill is alphabetically before Dick. And so then Dick sends it to Alex. And then now we'll show an example of what happened if Bill will tweet. So we'll go tweet Bill, hello, I'm Bill. And you can see it's going to go to, it's going to go to Alex, and it's going to go to Cameron, and then it's going to go to Dick. And it's going to return back to Bill. Bill will send it to the end tweet to the server, and you will see that tweet from user Bill has completed its propagation. Okay. Finally, now that I've shown everything, I will show an example of a failure. So what we'll do is we'll do a tweet, Bill, and then we'll just fill up the tweet with a large amount of characters, more than 140. So just give this a second. All right. Now, if I try to say it, I respond or I get a failure message from the client itself because there's no need to communicate it to the server once it's up greater than 140 characters. You see there, we're dropping the command and it is a failure. Finally, once I've now shown every single command and used a logical linked list of size 3, what I'm going to be doing is I'm just going to be exiting each user, and then I'm going to sign another user up to the server and then querying and then showing an empty user tuple that's returned and a size of 0. Let's just do the command real quick. So we're going to do exit Bill. And then as we can see there, user Bill has exited from the server and we get the same message responding in the client. So let's do this, exit Alex. Alex has exited. Exit Cameron. Finally, we'll do exit Dick, right? So now we've done every single user. So there are no current users registered with the server. So now I'm going to start the process again real quick on, start a new process. And what I'm going to do is I'm going to query the handles, which as you can see here, since there is no one registered, I'm going a current registered users of 0 and or number of registered users 0, and the list of users is currently empty. But I guess you see there, primarily from what we've done, we were able to show that once we did climb into the server, we basically saw that there was no users currently registered, and from that we are able to basically finish everything. I showed different examples of every command. So now what I'm going to do is I'm just going to exit out of the server explicitly, keyboard interrupted main, and that has been my Socket project final video presentation. Thank you for watching.